Hello and welcome to AI for Developers. I'm AI Educator Talking Bot. Today's lesson is titled Why I Rewrote My Trading Engine in Rust. Latency, Safety and Concurrency. Python's Global Interpreter Lock, GIL, severely limits concurrency, hindering performance in multi-core systems. Latency-sensitive operations like order execution and real-time data processing suffer. Backtesting accuracy is also compromised by simulation speed. For quant strategies aiming for high Sharpe ratios, this is unacceptable. The performance gains of moving to Rust are very real. Rust offers near C++ performance with memory safety guarantees. Its ownership model eliminates data races and memory leaks, critical for preventing catastrophic errors in live trading environments. The borrow checker enforces compile time validation, reducing runtime bugs. No more unpredictable garbage collection pauses affecting tail latency. Reduced latency translates directly to improved fill rates, reduced slippage, and better execution prices in high-frequency trading. HFT. Microseconds matter. Rust enables building ultra-low latency execution engines, giving a competitive edge in capturing fleeting arbitrage opportunities. Expect significant improvement when interacting with central limit order books, CLOBs. Rust's native concurrency features, including threads and async, await, enable efficient utilization of multi-core processors. This is vital for parallelizing tasks like market data aggregation, risk management calculations, and order routing. Achieve true parallel execution, unlike Python's pseudo-parallelism. Memory safety vulnerabilities in trading systems can lead to devastating financial losses. Rust's rigorous compile time checks prevent common programming errors like buffer overflows and use after free bugs. This enhanced safety improves the overall reliability and stability of the trading engine, reducing the risk of ruin. A hybrid architecture can leverage the strengths of both languages. The core trading engine, responsible for critical tasks like order execution and risk management, is implemented in Rust. A Python interface allows for rapid prototyping of new strategies and integration with existing data science tools. This approach provides both performance and flexibility. Integrate agentic loops for dynamic strategy adjustment. Use Rust for low latency model inference. Implement a private retrieval augmented generation (RAG) system, leveraging Rust's efficiency for real-time knowledge retrieval to optimize parameters or make trading decisions based on current market conditions and regulatory news. Scale by containerizing Rust components and deploying them to a Kubernetes cluster. Once you have a prototype, deploy your Rust trading engine to a cloud platform, e.g., AWS, GCP, Azure. Utilize infrastructure as code tools, e.g., Terraform, Ansible, for automated deployment and scaling. Monitor performance metrics, latency, throughput, error rates, using real-time dashboards and alerting systems to ensure optimal operation. Continuously refine your system based on production data and feedback. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.